Okay, today we're going to talk about solving quadratic equations. In our book it would be section 5.3. Let's start off with a few definitions. First, what is a linear equation? Well, of course, that's an equation that has degree 1, or the highest exponent on your variable is 1. A quadratic equation, well, the highest degree, or the degree of the equation, is 2, and that would be because x squared was the highest exponent on the variable. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. Alright, the zero product theorem. If a times b equals 0, then either a is equal to 0 and or b is equal to 0. So the only way you can get 0 as the answer to a multiplication problem is to use 0 as one of the factors, or possibly both. So these are some things that we use in this section, and we're going to have to know them as we go through. Alright, so let's start with example number 1. We want to solve the equation x squared plus 3x equals 18. Okay, well, here are the steps. Step number 1, get it in standard form. So we want to match this form up here, ax squared plus bx plus c equals 0. So we want to get it equal to 0. Now that's our goal with quadratic equations, get it equal to 0. So and another thing you want to do when you're getting it equal to 0, as I suggest as a best practice, is to keep x squared positive. So in this equation, I can see where x squared is right now. It has a positive 1 in front of it. So I will keep x squared where it is, and I will make the other side the 0. If x squared was negative on this side, well, then I would move all the terms to the other side, and I would make this side the 0. There's other ways to solve this, but this is what I consider to be best practice. Okay, so as we go through here, we're going to get rid of the 18, so we subtract 18 from both sides, and this side becomes then x squared plus 3x minus 18 equals 0. We've got it in standard form. Step number 2 is to factor this non-zero side, so we're going to factor this trinomial, and we've been using the AC method, or maybe the ABC method, but that's in another video of mine if you want to check on how to factor. Actually, because this one starts with a 1, we actually take what I call a shortcut. We're looking for numbers that multiply to be 18 that subtract to be 3. Okay? Since there's a 1 up front, we know our binomials will have 1x in the front of them. And then, of course, the numbers that multiply to be 18 that subtract to be 3 are 6 and 3. We have to assign a negative to one of them for our last times last to give us negative 18. And if we want the sum to be positive, then the bigger numbers has to be positive and the smaller number negative. So this turns out to be x plus 6 times x minus 3 equals 0. And then step number 3 is you set your factors equal to 0 and solve. Remember, we have the zero product theorem that says if we have a multiplication problem, that's what we're looking at right here. We have two parentheses next to each other. Multiplication is implied, so what we do is we take the individual factors, x plus 6, set it equal to 0. Well, you subtract 6 from both sides and you get x is equal to negative 6. That's one answer. And then you take this other factor, x minus 3, and you set it equal to 0. And of course, when you solve that, you get x is equal to 3. And those are our solutions. Okay, moving on. And go ahead and solve this one. I'll stop the video and give you some time to work it. Okay, so we look at this problem. We notice that the x squared term is negative where it is, and so what we're going to do is we're going to move the x squared term and the x to the first to the other side by doing the opposite. So underneath 9x squared, negative 9x squared rather, we put plus 9x squared, and we do that both sides. And underneath the positive 12x, we put negative 12x on both sides, and we proceed to add these together. Of course, this side's going to become 0. That's how we plan that. And over here, we just simply put it in the order that we would prefer in standard form, and that's going to be 9x squared minus 12x. The 4 is positive. We need a sign, so it's plus 4. Okay? All right, so when we factor this trinomial, my class has been using the AC method to do that. What we're looking for is two numbers that will multiply to be what our A number, which is 9, times our C number, which is negative 4, or 9 times 4 is 36. Two numbers that multiply to be 36, and again, that's A times C for our problem. And that at the same time, those two numbers add up to be B. Okay, so as we think about this, then if you have a positive product and a negative sum of two numbers, both numbers have to be negative. And if they have to multiply to be 36 and add to be 12, that'll be negative 6 and negative 6. So we'll put those in here. And then underneath this bottom one, we're going to put the C number, which is 4. So we divide both of these numbers by 4. And we're going to reduce. And in the AC method, if there's a fraction if there's a negative in the fraction, we prefer to have that on the bottom. So as I reduce this, I'm going to push the negative to the bottom, so I have 3 over negative 2 and 3 over negative 2. Now, what this tells us is the numbers that would be in a pair of binomials with x up front, and the top number goes with the x, 3, and the bottom number is the number in the back, negative 2. Top number 3, bottom number negative 2. So we have 0 is equal to this. Now, in some classes, this would be taught. You would be taught to recognize this as a perfect square trinomial. The fact that this is 3x to the second power and this is 2 to the second power, and 2 times 3x times 2 gives you the middle term, then you would know that this would automatically be this. You can also do these as treat them as regular binomials, and so that's what we choose to do in this class, is just to go ahead and factor them. We will deal with recognizing the perfect square trinomial later when we get into completing the square. Okay, so we're down here. Now we're going to set our factors equal to 0. So 3x minus 2 is equal to 0. And of course this is going to yield the same thing, so I'll only write it once, but I'll know that I got that same answer twice. And we add 2 to both sides. We get 3x is equal to 2. And we divide by 3, and x is equal to 2/3. And again, we would arrive at that answer 2 times. So basically, we got a duplicity of solutions here. This is x equals 2/3. Okay? All right, moving on to the next problem. All right, here's our example 2 now. This one's just a little bit more involved than the last one, because there's other terms that we have to do. So when we have these other terms, well, we just still need to get one side to equal 0. X squared is positive on the left-hand side, so I'm bringing everything over to the left-hand side. So we'd start by subtracting 3x from both sides, and I'd put it under its like term here, and we'll add 5 to both sides and put it under its like term on this side, and then we go ahead and add both sides. So we get 2x squared minus 20x plus 50 equals 0. Okay, now we're going to factor this. Now, another thing that we learned in the factoring section, you can look that video up, is that you always want to look for a common factor first. And so in this trinomial, there's a common factor 2. Now that 2 comes out, and what we're left in here with is x squared minus 10x plus 25 equals 0. And if we took the time right now to divide both sides by that common factor that's a constant, as you can see, it's going to cancel on this side. We get x squared minus 10x plus 25 is equal to, and then 0 divided by anything is still going to be 0. So what we've learned is that if there's not a variable in the common factor at this point, then the common factor really doesn't affect the answer any, or it doesn't lead us to an answer, and we can sort of dismiss it and move on. So we're going to factor this now. Okay, so with the AC method, we're looking for two numbers that multiply to be 1 times 25, or 25, and that add to be negative 10. Of course, it's two negative numbers that multiply to be positive and add to be negative, and it's negative 5 and negative 5. Okay, we could have done this with a shortcut method, but I started out with AC, so I'll finish it. And then we put that over the C number, 25. Now, it's not AC, this is AC. For this problem, AC and C look the same, but they're not always the same. I'm taking this number and putting it on the bottom, not what I have here. These happen to be the same this time, but they're not always. Okay, reducing this, pushing negatives to the bottom, we have 1 over negative 5 and 1 over negative 5. This becomes x minus 5 times x minus 5, and all that's equal to 0. Set the factors equal to 0 and solve. I'm only going to do this once. Add 5 to both sides, and we get x is equal to 5, but we arrive at that with two different times. Okay, let's give this one a try. Okay, first step would be to get the left-hand side to be 0 because x squared is positive on the right-hand side, and so we subtract 3x from both sides. Here, over here I just push out to the side because there's not a like term, and then I add 6 to both sides. I put it under its like term over here. When I add, I'm going to put them in the standard form, so the x is going to come second. So I have x squared, and then the 3x comes second, and then negative 10 and 6 is negative 4. From here, let's take the shortcut method of factoring this. We know there's going to be two binomials and there's an x up front. Factors of 4 that subtract to be 3. That's 4 and 1, and when you add them they have to turn out negative, so the bigger number is the negative number, so it's negative 4 and positive 1, and all that's equal to 0. Set the factors equal to 0. X minus 4 is equal to 0. X is equal to 4, and x plus 1 is equal to 0. Subtract 1, x is equal to negative 1. Those are our solutions. Okay, next example. And in this one, you'll notice that there is no constant here. Okay, we still want to get it equal to 0. We want to keep x squared positive, so we'll go ahead and subtract 20x from both sides. I'll just write it underneath here and then put it in the correct order. So we get 12x squared minus 20x equals 0. Now, step 2 was to factor. Now, in the last problem, when we got it equal to 0, we had a trinomial. Well, here we have a binomial. And as up to this point in our algebra class, the only thing that factors that's a binomial is the difference of two squares. That's a squared minus b squared. Now, there are others, but we haven't gotten to them yet. So that's the rule is it's a minus b times a plus b. Now, if it's not this right here, the only thing you can do is take out a common factor, and that would constitute factoring it. So, as we look at this, 12x squared minus 20x, I notice that they both have x. Okay, so I can at least factor out x. You can always factor out the x to the smallest power if they both have it. And then 12 and 20, of course, that's a 4. So I've established that the common factor is 4x, and I'm going to take that out. So that'll be left with 3x here, because 3x times 4x is going to be 12x squared. And then minus 5 here. And at this point, I'm looking at this. X is not squared. These are not perfect squares. It doesn't fit this form. This is as far as I can factor it. And now, take my factors and set them equal to 0. So 4x is equal to 0. And 3x minus 5 is equal to 0. Solving this one, you divide both sides by 4, you get x is equal to 0. Over here, when we add 5 to both sides, we get 3x is equal to 5. When we divide both sides by 3, we get x is equal to 5/3. And those are our solutions. You give this one a try. Okay, well, remember that we want to keep x squared positive, so right now x squared is negative, so I'm moving it to the other side. There are other ways of dealing with that. You could move it to the left-hand side and multiply by -1. We're just going to do it the same way each time. We're going to move the x squared in this class. Okay, so we add 6x squared to both sides. We get 0 on this side, and the x squared first, so it's 6x squared, and it's minus 21x. And if you notice, there is a common factor, 3 and x, so we can factor out a 3x out of this. What's left is 2x minus 7. We set 3x equal to 0, and that's x is equal to 0 when you divide by 3. And you set 2x minus 7 equal to 0. You get 2x is equal to 7 when you add 7 to both sides, and you get x is equal to 7/2 when you divide both sides by 2. There are our answers. 0 and 7/2. Okay, now we're going to deal with what I mentioned earlier was the difference of two squares. And this is the formula. A squared minus b squared is equal to a minus b in parentheses times a plus b in parentheses. So in example number 4, we're going to go ahead and get it equal to 0. So we're going to subtract 16 from both sides. We get 25x squared minus 16 equals 0. Okay, now what we want to do at this point, I don't see a common factor, so the only other thing that I might be able to do is factor it by formula. In other words, just using this formula up here, it takes care of the signs and the numbers, but we have to see if this indeed fits into this form. So the way I do that is this. I put a parentheses and I square it, and minus parentheses and squared. And I sort of ask myself, can I put a number in here and square it and get this? Well, you're sort of taking the square root of this right here if you want to know what really is going on, but this is another way of looking at it. So I can put 5 and x in here, and if I square both of them, I'll get this. What can I square and get 16? 4. So what I've done here is established that a is equal to 5x and that b is equal to 4, and all I do is take our formula up here and plug in 5x for a and 4 for b. So this becomes 5x minus 4 times 5x plus 4. I factored it by formula. It did all the thinking for me. I just plugged numbers in where it said a and b. Now we set our factors equal to 0, so 5x minus 4 is equal to 0. 5x plus 4 is equal to 0. Adding 4, we get 5x equals 4. Dividing by 5, we get x is equal to 4/5. Over here, we subtract 4 from both sides. We get 5x is equal to negative 4. We divide both sides by 5, and we get x is equal to negative 4/5. Okay. Let's try one of these. Okay, well, remember we want to keep x squared positive, so x squared is negative where it is, so I'll decide to move it to the other side by doing the opposite or adding 4x squared to both sides. What I get on this side is 0, and over here I get 4x squared minus 36. Now, if you're one of those persons that always likes to see the stuff on the left-hand side and the 0 on the right, help yourself to the symmetric property and just switch sides. That's perfectly okay. Now that we get it like this, there is a common factor here, and the common factor is 4. So 4 comes out, and we get x squared minus 9 is left. And we said that if the common factor was a constant and didn't have a variable on it, we could basically disregard it because it would not lead us to a solution. Or basically, if we divide both sides by 4, it goes away. Now, is this the difference of two squares? Could we put it in this form right here and be equivalent? And yes, we can. X to the second power is x squared. 3 to the second power is 9. Factoring this with the formula, it's going to be a minus b times a plus b, or x minus 3 times x plus 3 equals 0. And set our factors equal to 0. X minus 3 equals 0. Add 3. X is equal to 3. X plus 3 equals 0, and then subtract 3 from both sides and get x is equal to negative 3. Now remember we said that that common factor would not lead us to an answer. Suppose with this we didn't recognize the common factor. Suppose we just said, hold it, 4x squared is 2x raised to the second power minus 36 is 6 raised to the second power, and did that. And wrote that as because this is the difference of two squares as it stands. Well, let's see what happens. What I told you over here is it wouldn't matter. But if we left it in solving an equation, then we get 2x minus 6 times 2x plus 6. You set those factors equal 0. 2x minus 6 equals 0. 2x is equal to 6. Divide by 2, x is equal to 6 divided by 2 is 3. Get the same answer. And then if you do 2x plus 6, well, you wind up with x is equal to negative 3. Now, the common factor that's a constant in solving an equation doesn't affect the answer. So if you miss it, it's not a big deal. If, on the other hand, the question asks you to factor this, then any common factor is important to the answer. Okay? Let's take a look at the next problem. All right, now here's where we're going to deal with finding the zeros of a quadratic equation. Okay, so to find the zeros of a quadratic equation like y equals ax, this should be ax squared here. Let's add the squared. Ax squared plus bx plus c, you let y equal 0. Finding the zeros, y becomes 0. And then basically after that you just solve it. So if they ask me to find the zeros, basically they're asking me to find the solutions to the equation when y would equal 0. So we put in a 0, and then it's just like these other problems that we've worked. So it's just a kind of a differences semantics here, how they're asking you to do this. So we put that in, and then we factor this trinomial. We'll take the shortcut method because we know that it's got to start with 1x for the first times first to give 1x squared. Factors of 6 that subtract to be 1, 2, and 3. So there's a 3 here and a 2 here. And when you add them, the biggest one's got to be negative, so it's minus 3 and plus 2. Set our factors equal to 0. X minus 3 is equal to 0. X is equal to 3 when you add 3 to both sides. X plus 2 equals 0. And you subtract 2 from both sides and you get x is equal to negative 2. You try one. Find the zeros of this one. Okay, again, if they ask us to find the zeros, then there's probably going to be a y in the equation. We change it to 0. So this equation becomes this, and then we find the solutions. Okay, well, looking for two numbers that multiply to be a times c is 3 times negative 5 or negative 15. And the two numbers have to add up to be the b number, which is positive 14. Let me see. A negative product and a positive sum, you got one positive and one negative number, and they subtract to be 14. Well, that's pretty easy, 1 and 15. Now, when you get these with a negative product, don't decide where the negative goes based on the multiplication problem, because it'll turn out to be negative 15 if you put it on either one of these. But down here in the addition problem, this will only work one way. If we want the sum of these numbers to be 14, the negative's got to go with the 1. So we put the negative there based on the addition problem. Again, dividing by the c number, which is negative 5, and we put negative 5 underneath. And then we reduce these fractions. This reduces to 1 over 5. And 15 over negative 5 reduces, when you divide by 5, to 3 over negative 1. Now you could say this works out to be negative 3, but for our purpose we need a top and a bottom number, so we'd never in the AC method reduce a fraction to an integer. We'd always leave the denominator as 1. Okay, so 1 over 5 becomes 1x plus 5. Again, the top number goes with x, the bottom number's in the back, it's positive, so I put plus 5. And here it becomes 3x and then minus 1, and all that's equal to 0. Okay, set your factors equal to 0 and solve. At subtracting 5, we get x is equal to negative 5. 3x minus 1 is equal to 0. Based on the zero product theorem, if you have a multiplication problem, you have to have a 0 in the problem for it to equal 0. And adding 1 to both sides, 3x is equal to 1. Dividing by 3, x is equal to 1/3. X is 1/3. X is negative 5. Let me state this here, that you notice we're getting two solutions, and since this is a quadratic equation, we know that the highest power, or the degree, is 2. And what that tells us is that the most number of solutions that we'll get to a quadratic equation is 2. Now you can get less, but that's the most that you can get, is the degree of the equation, and this has degree 2. And that looks like it's the end of the video. Thank you for watching, and we'll see you next video.